NASA says its Voyager 1 probe is sending usable information to Earth again.
A machine from the 1970s, drifting alone through deep space, 15 billion miles from home. For 46 years, Voyager 1 obeyed its design. It sent data, it never turned, it never listened. Then, without warning, the antenna shifted, and something answered. Not from Earth, not from any known star, but from a patch of sky that should have been empty. What happened next wasn't just strange, it was impossible. Built to leave.
Mission, we have a liftoff.
Roll program is in on time.
Voyager 1 launched quietly on September 5, 1977, a slim body, 800 watts of plutonium-powered electricity, and a memory smaller than a single JPEG. There were no advanced systems, just a transmitter built to send data back home, not to listen, not to react, and definitely not to turn. Its only job was to leave. And it did. It raced past Jupiter, then Saturn, then kept going. It flew beyond Pluto. Crossed the heliopause in 2012, that invisible edge where the sun's magnetic field fades into interstellar space. And now it floats 15 billion miles away, still powered, still transmitting, the farthest object humans have ever touched. For over 40 years it drifted in silence, until that silence broke. With no sensors, no receivers, and no commands from Earth, Voyager 1 responded to something. Something that wasn't supposed to happen. The shift. When Voyager 1 crossed the heliopause in 2012, it entered a region no spacecraft had ever breached. The borderless, unnamed stretch of space beyond the edge of the sun's influence. It's a place so distant that even the closest stars appear frozen in place, offering no pull, no light, and no sound. This is interstellar space, the large, empty expanse between solar systems. Here, the sun is just another pinprick of light, its magnetic field stretched too thin to reach. There are no planets to orbit, no gravitational fields to guide it, and no solar wind left to push against its body. By all expectations, nothing should happen here, and yet that's when something did. Without any command from Earth and with no external trigger detected, Voyager 1 adjusted its orientation. It turned gently, but deliberately, towards a patch of sky that appeared completely empty. There were no galaxies, no stars, no known celestial mass. Just blackness. And for a spacecraft that was never built to respond to its surroundings, this turn wasn't just unexpected, it was illogical. The glitch that wasn't a glitch. On November 6, 2023, Voyager 1 sent back a transmission that looked off, not broken, just wrong. The data came through distorted, like a static-filled stream that didn't follow any known pattern. At first glance, NASA's engineers chalked it up to the usual issues: cosmic radiation, degraded wiring, or maybe just a memory glitch. It made sense. This was a 46-year-old spacecraft, running far past what anyone ever expected. But then something unusual happened. Voyager's fault protection systems designed to take over during emergencies suddenly kicked in. These protocols don't activate lightly. They're built for serious problems, like when the spacecraft begins to spin uncontrollably or loses contact with Earth. But this time, they engaged with no clear trigger. Telemetry logs became unreadable. Orientation records vanished. Even some of the onboard clocks began to drift out of sync. The signal didn't just get weaker, it morphed into something different. There was no command from mission control. And yet, Voyager started acting like it had been hit by something invisible, like it was reacting to an event it couldn't process. This wasn't random static or data loss from deep space exposure. It was something else, something that reached deeper into the structure of the spacecraft itself. And whatever it was, Voyager couldn't explain it. Not long after the emergency systems kicked in, Voyager 1 did something it should never be able to do on its own. It turned. The spacecraft's high-gain antenna that's supposed to stay locked on Earth shifted position. But it didn't realign with mission control. Instead, it aimed somewhere else entirely, toward a patch of sky with nothing visible. What made the movement even stranger was how it happened. The shift didn't involve the spacecraft's thrusters. There was no propulsion recorded or firing of jets. It was as if the orientation simply changed on its own. NASA ran through every scenario. No command had been sent from Earth. No software had been updated. Nothing in the control system had changed. From every angle, Voyager should have stayed still, but it hadn't. This was a clear, deliberate reorientation, which didn't make sense because Voyager 1 was built to follow instructions, not act on its own. After Voyager 1 turned toward the empty patch of sky, its onboard sensors picked up something even stranger: a torque event. That means the spacecraft didn't just shift direction, it rotated physically. The gyroscopes recorded it clearly. This wasn't a software glitch or random drift. It was a real, measurable change in orientation, small but definite. And yet, nothing on the spacecraft should have caused it. The thrusters didn't fire. The logs showed no activity. Solar pressure was ruled out. Voyager was far too distant from the sun for light to exert any real force. There was no sign of debris, no evidence of an impact. A machine drifted through the most silent, empty region of space known to humanity, and somehow it moved. The null void. Once the torque event was confirmed, NASA did exactly what it's trained to do. Engineers ran full diagnostics and checked power levels. They cross-referenced flight logs, looked for signs of system failure or unexpected inputs. And they found nothing. There were no electromagnetic pulses, no power surges, no radiation spikes, nothing from any nearby satellite to suggest external interference. Voyager's instruments were stable, its systems were operating within expected parameters. On paper, everything was normal. Just to be sure, the team ran simulations. They tested whether aging hardware or degraded components could have triggered some phantom command. But the data didn't line up, the numbers didn't match. This wasn't a ghost signal or a random twitch from dying circuits. The reorientation was real, the torque event was real, and neither one had a cause that anyone could find. Once engineers had ruled out every known explanation, they were left with a question that no one really wanted to answer. If Voyager's systems hadn't caused the shift, if there was no technical failure, no solar radiation, no micrometeoroid strike, then what exactly made it move? The only answer left was that something external had interacted with the spacecraft, and not in the way space usually interacts with machines. This wasn't a collision. It felt like a nudge. A subtle, intentional adjustment. Not enough to break anything, but just enough to steer. Almost like something out there understood Voyager's design and wanted to shift its course without disrupting its systems. The longer they stared at the data, the more it seemed like that patch of blackness wasn't random. It wasn't nothing. It was a direction. It had come to rest with its antenna locked onto a very specific part of space. It was aligned with a point researchers had only ever written about, a theoretical region some called a null zone. It's a kind of pocket in space where gravitational forces from different directions perfectly cancel each other out. It's not something you stumble across, and certainly not something an old spacecraft should be able to find, let alone point itself toward. Voyager wasn't designed to detect null points. It had no software for that, no hardware to measure them. The probe didn't just face the zone, it held a position. Its antenna stayed locked, like it was receiving something. There was no entry in Voyager's command history to explain it, no programming that told it to do this. So the team stopped calling it a fluke and started calling it something else, targeted. Sound and data. Right after Voyager 1 aligned itself with the null point, its plasma wave subsystem picked up something it hadn't heard before. It was a tone, a soft, steady hum, not the kind of electromagnetic turbulence common in deep space. This was cleaner than that. It held steady at around 3,000 Hertz and it didn't waver. The signal pulsed with a rhythm so consistent it felt designed and structured. The kind of pattern you'd expect to find not in natural radiation but in music theory. But this wasn't new. This hum had been there for years. Voyager's strange reorientation had simply put it in position to hear it clearly without distortion. The alignment hadn't just uncovered the sound, it had amplified it. Researchers started calling it the plasma melody. When the waveform was analyzed, they found mirrored structures. The pauses were evenly spaced. The tone repeated itself in precise intervals. Its patterns echoed with math. It moved like a melody written in numbers. NASA didn't just bring in physicists. They called in acoustic engineers, people who work with harmony and structure for a living. And almost every one of them said the same thing: this wasn't random. It was balanced and symmetrical. It didn't feel like a signal someone had transmitted. It felt like it had been waiting to be found. But it wasn't more than just sound. Buried inside the transmission was something else: data. It wasn't the standard kind Voyager usually sent. This one had no temperature readings, radiation spikes, or velocity logs. The telemetry included layers of structured information that didn't match anything Voyager had been programmed to capture. It wasn't logged in its onboard memory. It didn't come from any known software protocol. The formatting was strange: hexadecimal strings, recursive formulas, prime number chains, fractal symmetry. Some of the numbers even matched known astronomical constants. But measured at a precision Voyager's aging instruments couldn't possibly achieve. Voyager didn't have the hardware to detect this kind of detail, and it certainly didn't have the logic systems to compile it. It was as if the probe had been used. Something had inserted this code into the signal, layered it into Voyager's outgoing data stream like a hidden file riding inside a normal transmission. A vessel carrying someone else's data, straight back to Earth. Most signals in space aren't precise. Even the most focused energy tends to disperse across vast distances, like a flashlight lost in fog. The signal that hit Voyager didn't spray out across multiple trajectories or brush past other spacecraft. It came in clean, direct, and narrow. It hadn't just reached Voyager by chance, it had found it. None of the other probes in similar trajectories, not Pioneer, not New Horizons, reported anything like this. The signal didn't spill into their data streams. Whatever this was, it was focused on Voyager 1 alone. This made researchers stop and ask, how? How could anything know not just the path Voyager would take, but when it would arrive? How could it know Voyager's location? Not generally, but specifically. Halo in the dark. When Voyager's antenna shifted, it didn't just drift off course or lose focus. It locked onto a direction, a section of sky that, by all known records, contained nothing. But that sudden orientation wasn't ignored. Back on Earth, something about it felt too deliberate. So ground-based observatories decided to investigate. They calibrated their instruments, aimed high-exposure infrared arrays toward the exact region Voyager had turned to face, and waited for something to stand out. At first, the results were just as predicted: empty. But over time, the data began to change. Weeks into the scanning sequence, the arrays started picking up a glow. It was faint at first, shimmering at the edge of detection. A halo. It didn't stay still, and it didn't shine with a constant light. It faded in and out, like it was blinking. Even stranger, it seemed to respond to solar flares. Each time the sun emitted a burst of charged particles, the halo flickered back, just moments later, not simultaneously, but in a way that felt timed. It was as if whatever was out there was syncing to solar rhythm, matching energy with energy, listening, responding. The glow wasn't a reflection of sunlight. It wasn't passive. It moved with intention. Silence. After all the strange behavior and the realignment came the most unexpected moment of all. Voyager 1 went silent. For 12 full hours, there was nothing. And for most machines, especially those that have traveled billions of miles through space, 12 hours of silence might not raise alarms. But Voyager had never gone quiet. Not like this. Not in decades. It had survived the solar storms of the 80s. It had withstood deep space radiation, failing instruments, and cosmic dust. And through it all, it kept talking. Its signal might have been faint at times, delayed, warped by distance, but it had always been there. And then, as suddenly as it vanished, the signal returned. But it wasn't the same. The data stream that Voyager sent back looked off. Its internal clock had reset. It wasn't lagged, but fully restarted. The timestamps didn't match any known timeline from Earth. It was as if Voyager had existed, just briefly, somewhere else, somewhere with different rules. There were no signs of mechanical correction. But something about the probe had changed. Voyager itself felt different. As if whatever it had passed through during those 12 hours hadn't just touched its systems. It had touched the machine. Cosmic microwave background. The cosmic microwave background, known as the CMB, is often described as the afterglow of creation. It's the oldest light in the universe. A soft, ever-present static left behind by the Big Bang. And by all accounts, it should never change. But shortly after Voyager's strange reorientation and 12-hour blackout, a research team from the European Space Agency decided to run a cross-check. They took the last known trajectory of the spacecraft and lined it up with deep-field CMB data, searching for even the faintest fluctuation that might connect to the anomaly. What they found defied expectation. Buried inside the microwave background was a distortion, a ripple too structured to be dismissed. It was a silhouette, a faint shape, subtle but persistent, etched into the static like an echo. And somehow, impossibly, that shape aligned perfectly with Voyager's current course. Every coordinate from that silhouette matched where Voyager had ended up. And when they traced the data back, it got even weirder. This ripple hadn't appeared in the aftermath of Voyager's blackout. It had been there already. They found the same pattern across decades of readings, from Planck, from WMAP, even older deep sky missions. Different sensors, different tools, different timelines, and still the exact same anomaly. It had always been there, which means somehow the background static of the universe already knew where Voyager 1 would be. The message inside the signal. By now, it was clear that the signal Voyager had sent back was more than just broken telemetry. It was something deliberate and designed, but no one had the tools to read it. NASA's instruments couldn't decode it. Traditional software failed to parse the structure. It wasn't written in any known programming language. So the team turned to something new, something built not just to process information, but to interpret complexity itself. They used a Majorana chip, a quantum processor called the Majorana 1. Unlike regular computers, it didn't solve problems through step-by-step equations. It worked through probability, mapping patterns across multiple potential realities, adapting to symmetry, recursion, and uncertainty. The same principles that define the universe at its smallest scales. They fed Voyager's raw signal into the chip and waited. Gradually, the chip began to pick out structure. It started recognizing mirrored patterns, sequences that folded back on themselves, loops that aligned like grammar in a language no one had taught it. The signal began to unfold like a sentence, a message that wasn't written in English or in binary or in Morse, but in logic, in structure. And then it stopped. The chip produced one final output, just a single line. It was a question. Are you ready to listen? This wasn't just a message sent across space. It was an invitation. With the question decoded, attention turned back to the signal itself. If this was a message, then maybe it carried an identity. So they began peeling it apart, one digital layer at a time. And at the very core of the transmission, beneath all the math and structure, they found something deeply strange. A tone. A steady, perfectly tuned hum, locked at 3,000 hertz. It didn't behave like static. It didn't degrade like background radiation. It didn't scatter like noise. It held rhythm. And more than anything, it sounded like music. NASA brought in experts from outside the science world who understood the physics of harmony. They all agreed on one thing. The sound wasn't random. It echoed with palindromes, melodies that folded into themselves. It used intentional silences, timed like rests in a musical score. It held intervals that matched standard musical scales. This was patterned and composed, structured with the grace of math and the language of sound. And then, just as clearly as it began, it ended. As if someone, somewhere, had turned the switch off on purpose. After the tone dropped and the signal went quiet, engineers around the world began digging for explanations. A physical event that could explain everything. Maybe it was a solar flare or a micrometeorite dust that hit the probe. Not one piece of data matched the conditions needed to cause the transmission. Every diagnostic came back clean. Voyager wasn't broken. Whatever touched Voyager in that black stretch of space had broken the rules. Speak or respond. For a long time, everyone assumed Voyager had received something, some kind of signal aimed at the spacecraft from across the galaxy. A one-way transmission designed to be picked up by something listening. But that theory didn't hold up after everything that followed. Because as the data continued to unravel, the sequence started to feel less like a message sent to Voyager, and more like a reaction triggered by Voyager. From the subtle musical tone to the strange rotation and the coded data. Every one of those anomalies lined up not with an incoming transmission, but with a specific location. It didn't feel like a call for attention. It felt like an answer. Something happened the moment Voyager entered that particular patch of interstellar space. An idea started to take shape. What if Voyager didn't receive a message at all? What if it knocked on something, and something knocked back? Whatever responded didn't do so with panic or confusion. It replied in rhythm, as if it had been waiting to return one. Which means this wasn't just about Voyager detecting something. Something else detected it, recognized it, and then made the choice to respond. NASA's quiet breakdown. To the public, NASA's updates were calm and measured, polite mentions of signal anomalies and ongoing analysis. The kind of vague, technical language you'd expect from a government agency trying to keep things quiet. But behind the scenes, it was different. Internal documents were stamped, and high-level meetings were held off record. Entire processing teams were retasked to focus solely on Voyager. Telemetry was pulled from archived backups. System simulations were run again and again, looking for explanations that never came. At the Jet Propulsion Lab, computing resources were rerouted. Engineers who hadn't worked on Voyager in decades were called back into active consultation. Even the Department of Defense quietly logged interest. The timeline made no sense. The signals defied known physics. And the data Voyager had sent back looked like it had passed through something far more advanced than any man-made system. A 1970s-era spacecraft had entered a region of empty space, spontaneously changed direction, picked up a patterned signal it wasn't equipped to receive, and then returned from total blackout with cleaner, stronger data, including code formats it was never designed to understand. NASA didn't panic because something failed. They panicked because something worked. Something they didn't create and didn't expect. Something they didn't even know how to process. And in all their decades of deep space exploration, no moment had ever hit harder than that 12 hours of silence. Because for that stretch of time, Voyager was gone. And whatever it saw or passed through changed everything. After months of rechecking logs, testing every theory and searching for any explanation that could make this easier to swallow, they stopped calling it a malfunction. They stopped treating the signal as a corrupted file. Hidden beneath the telemetry were layers of structure too precise to ignore. Frequencies that repeated with exact timing, harmonics that mirrored each other. NASA engineers gave it a name: field interaction. That's the technical term they settled on. Because the energy surrounding the probe didn't behave like radiation or dust or interference. It didn't scatter or explode. It moved like it had purpose. When Voyager turned, the field turned with it. When the transmission spiked, the rhythm returned. When the systems rebooted, the signal sharpened. And the beam itself wasn't broadcast across space like a flare or a pulse. It was narrow and controlled. Everyone who has seen the raw, unedited breakdowns of these transmissions agree on the one truth that can't be shaken. Voyager wasn't drifting alone. Something found it. Something waited. And when the moment came, it answered.